Perfectly controlled movements, high precision timing, dancing. It's probably one of the oldest human art forms, but the best dancers can still take our breath away. It's like looking at the sky, see the stars revolving. And that's exactly what the European Space Agency is going to do with the newest mission, Proba-3, bring up to the sky the art of dancing.
Once Proba-3 will be in orbit and work as a pair and demonstrate formation flying, then Proba-3 will be certainly Europe's and probably world's first high-accuracy formation flying missions ever built and flown. But they will not just drift apart, they will maintain their position and their attitude one in respect to each other, such that the two spacecraft will be like two dancers in sync, really follow each other and make sure that they are really coupled and do the like virtually rigid structure in space.
The main technical challenge of the mission is to keep the two satellites at a relative position and attitude within 1 millimeter error. It is like shooting an arrow from 150 meters away and trying to get the center of the target within 1 millimeter. It's extremely challenging. And you have to consider that this you have to do in orbit, where the orbital velocities are from 1 kilometers per second when you are at apogee to 10 kilometers per second when you are at the perigee of the orbit. We will build upon the existing expertise in relative dynamics, for example, for the rendezvous with the station. But up to now, worldwide, the best accuracy that has been achieved in relative positioning and attitude is in the order of centimeters. And now we're going for one order of magnitude better, so we're going for accuracy of millimeter. All the technologies for relative navigation, they were built upon existing technologies, for example, optical links, cameras for navigation, and inter-satellite link. But we will improve it and we'll bring it to the level of accuracy which is required for formation flight.
Observation from space are not different than observation from ground, so if you want to look further into space or if you want to look at things which are smaller and smaller, you need larger and larger instruments or larger and larger telescopes. So for the same reason that telescopes grow bigger on ground, you needed to have spacecraft growing bigger into space, which are even beyond the capacity of being launched as a single spacecraft.
In fact, Proba-3 mission will demonstrate the ability to rigidly align segments in space, like telescope segments, in order to form a virtual instrument bigger than anything that could ever be launched in one piece. In case of Proba-3, the instrument is a coronagraph. So we have the Sun and we have two satellites. One of the satellites will create an artificial eclipse in order that the second satellite can study the corona and can study this area, which usually is hidden by the sun glare. The sun is 1 million times brighter than its corona, so eclipsing it is essential in order to study the corona and revealing, in fact, the most mysterious area that for the solar science that needs to be studied. So Proba-3, in the course of demonstrating that two small satellites can do the job of one big satellite, one virtual big satellite, will become a major scientific tool, engineering tool, and also a breakthrough mission.
The precise formation flying demonstration mission, that we also call Proba-3, will bring a new set of eyes on the Sun and a new way of designing space missions. So it's time to dance.